Okay, guys, so on this video, what you're doing is the first part's pretty much review, okay? This is stuff you're just solving these proportions. So make sure you're either using scale factor, solving for the variable, or you're setting up a um, a proportion equation, a cross product equation. So show me those, show me that you went through the steps of solving, and then on the last one, make sure you give me an answer. So on example 4 here, you should be telling me that the length of the blueprint is blah. Okay. Okay. All right. Just hit pause and start doing these problems. Because if you got these, you got them. If not, then I'll do the extended part where you can watch the video and the explanation of it. But this is review. So hit it. Okay. So hit pause, do these problems, hit play and see if you got the right solutions and if you set up the equations right. Okay. Good luck. All right. So here's your solutions. And I showed you what the cross product equation would be. So you're looking at these now. Should be checking to see if you got the right cross product equation if you use that, and then make sure you got the right solutions, right? And this last one, that one probably the tricky one, but again, like I've shown you, put down your units so you know what you're comparing. So you always have one of the measures on the top, one of them on the bottom, and then the way I set it up, I looked and I said 25 millimeters is 10 meters. 6 meters you got to be careful. It's the 6 meters, right? So that would put that there, and we're trying to find the length on the blueprint, which would be 15 millimeters. And on the first one, you would have gotten that you would have had to round, but you get that V equals 15.89. On the second one, you would have gotten P equals 13.5. And on example number 3, you would have gotten B equals 40.09. Okay. So again, what you're doing is you're going to look at this, and if you made a mistake, then you're going to look and see where your mistake was, and see if you can solve it yourself. If you could catch your mistake, if you can't catch your mistake, then you're going to watch the extended video, and the extended part of the video where I explain these problems all the way through. Okay. But if you've aced this, then you're just going to go on to this new part of the lesson. You don't have to do the review of it. You know you got it. You're probably going to do fine on the review, and then we'll go from there. Okay? Right. So now, when we look at all of these, there's a significant thing that happens. We have an equal sign here, right? And that tells us that all these relationships are proportional. Okay? When that equal sign means these two are equivalent, they're proportional. Even when we're talking about using a scale drawing, the everything's supposed to be proportional in that, okay? But what we're going to talk about next is how do we tell if a relationship is proportional? So when we're looking at these problems, we have to determine if it's proportional. And then what we find is what's called K. It's the constant of proportionality. Okay? So you want to write that down. And we're always going to say that K equals y over x. When we're talking about a graph, we're talking on a table, we're always going to identify it as y per x, right? And this one, y is always the dependent variable, and x is always the independent variable. All right, so that's what you want to have written down there, okay? So if we're doing y per x, right, then when we see this per, we know that this is the y and this is the x, right? So it's not the y equals x, it's the per, right? So it's going to be y over x. So time is our y and kilometers are our x. So we're going to put y over x here on each one of these. So if I look, here's the y. I'm going to put 4 over 24. I'm going to put 7 over 42. I'm going to put 9 over 54. Now I'm going to simplify these, right? I want to know if these are the same unit rate, okay? And so when we simplify these fractions, we're going to get that this first one is 1 over 6, right? And the second one is 1 over 6. And the third one is 1 over 6. And that's in minutes per kilometer, right? So that's our units. And so if we look, they are all the same. 1/6, 1/6, 1/6. So we would say, yes, this is proportional. We would say that our constant of proportionality is 1/6. Okay? It's the unit rate of 1/6 minutes per kilometer. So you really have to pay attention to what they're asking you because like I personally would not have done it that way, but they give you this right here that you have time per kilometer. And so you know you're going to put minutes over kilometers, right? And so this means K, which is that constant of proportionality. See, this is constantly 1/6 if it's proportional. So your constant of proportionality would be 1/6 minutes per kilometer. But normally you would talk about kilometers per minute. Okay? So you have to be really careful and look at what they're asking you to do. And so when you look at this, it says now predict how many minutes it would take to travel 92 kilometers. Well, so now you're just going to set up a proportion. Okay? So you're going to say, I know that I have 1 minute, and you're going minutes over kilometers, right? And your original is 1/6. And now what they want to know is if you traveled 92 kilometers, so you have to put the 92 down here, how many minutes would that take? Right? So at this point, if you're using just cross products, if you want to just get used to one way, the most productive, the easiest, most accurate way, the one that's going to work every time is to use cross products. So you just say that I have 6 times m equals 1 times 92, which is just 6m equals 92. And then to solve this, you're going to divide both sides by 6. You get m equals 15.3 repeated, right? So you'd say 15.3 minutes or 15.33 minutes. It would take you 15.33 minutes to go 92 kilometers at that pace. Now there's another way to do this, okay? If you look at it, we have a formula that we're going to talk about is y equals k times x, right? And they said x was our kilometers and y is our time, right? And we said our constant of proportionality was 1/6. So you could say that y equals 1/6 times x. X is the distance, right? They want to know how far it takes us to go 92 kilometers. So you just say y equals 1/6 times 92, which gives you y equals 15.3 repeated. And you just remember that y is the time, which is minutes. So that means it's going to take you 15.3 minutes to go 92 kilometers. Okay. All right. So we'll move on to this next table. Okay. And Eric's having a party. He'll have 2 tables for every 6 guests. Complete the table, this table below. Okay. This table, not how many tables he's using. So the number of tables and the number of guests. So you just have to put some numbers in. And if it's going to be a proportional relationship, right? So the number of guests, if he has 6 guests, he's going to have 2 tables. You could plug in other numbers. Okay, you just need to plug in the other number. I'm not really sure where this problem goes, but you're going to just look and say, so it's, if you had 12 guests, right, he'd have 4 tables. If he had 18 guests, he'd have 6 tables. If he had 24 guests, notice I'm just increasing by 6 each time here, and I'm increasing this by 2, right? There'd be 8. Now notice there's a constant rate of increase here, but not always is a constant rate of increase going to equal a proportional relationship. So if I want to know if this is a proportional relationship, I have to put y over x, right? And it seems like the independent variable, we're trying to determine how many guests he can have, and that's determined by the number of tables he has. So the dependent variable, the one that depends on the other, is our number of guests. So we'll call this the y, because how many guests you can have depends on how many tables you have. And so x is the independent variable. So what we're going to do is just look at what y over x is, right? So we can determine the constant of proportionality. I'm going to erase this. Okay, so if we look, I'm going to have 6 over 2 and 12 over 4 and 18 over 6 and 24 over 8. Now I'm going to simplify these. 6 divided by 2 is 3. 12 divided by 4 is 3. 18 divided by 6 is 3. 24 divided by 8 is 3. Are those all equivalent? If they are equivalent, if 3 is equal to 3 is equal to 3, that means I've got 3 people per table, right? That's people, tables, so it's people per table. So my k equals 3, because I can know how many people I can have by multiplying that times how many tables I have. How many people can I serve is determined by how many tables I have. Okay. So let's look at these now. What we want to do is just, all you're going to do right now is put y over x. Okay. And if you get y over x on each one of them is the same unit rate, when you simplify it, if you get the same unit rate, then it's proportional. If it doesn't have the same unit rate, it's not proportional. So if I look, I have y over x, this is 20 over 8. This one is going to be 24 over 10. This one's going to be 28 over 12. Okay, so now I'm going to simplify these into a unit rate. In other words, I'm going to have the denominator be 1. Okay, so 20 divided by 8 is 2.5. 24 divided by 10 is 2.4. 28 divided by 12 is 2.3 repeated. Well, are these equal? That's the question. Are these equivalent? And they are not. So this is not proportional, right? Because they don't have the same unit rate. So I know that's not proportional. We're going to do the same thing with table 2. Table 2, again, we write out y over x. So fill that out. So for each one of these, you're going to write the ratio of y over x. And you're going to simplify each one of these. Well, so 18 divided by 6 is 3. 21 divided by 7 is 3. 24 divided by 8 is 3. So our question is, are these equivalent? And yes, they are. So if the unit rates are all equivalent, then this is proportional. My justification is it's proportional because they all have each relationship has the same unit rate. Therefore, it's proportional. And if it is proportional, that unit rate is k. So y is 3 times x every time. So the equation would be y equals 3 times x. Remember, k is the constant of proportionality. Okay? All right. Okay, so that's the gist of this. We're testing to see if it's proportional. When we look at a table of values, we take each one of those data sets, the y and the x, put y over x, right? So we have that k equals y over x. If y over x is constant, so like this one, it is constant, then it's proportional. If it's not constant, as like this one, then it's not proportional. All we have to say with the not proportional is they don't have the same unit rate. Okay? But on this table 2, it is proportional because when we put y over x, we got 3 every time. So it's proportional because it has the same unit rate. The unit rate is y is 3 times x. So k equals 3. So our equation is y equals 3 times x. Okay? All right. So that's what we're testing. Is it or is it not proportional? So now you do it with these two. Determine if they're proportional. Just do the same thing I did with this one. Okay? You're going to take their unit rates. You're going to take each one, come up with their unit rates, putting y over x, right? For each one, you're going to write it out down below, and you're going to simplify below that. If they come out with the same unit rate, they are proportional. If they don't have the same unit rate, they're not. Okay, so calculate that. Go ahead, hit pause, do that. Once you're done with that, you determine, remember, if they are proportional, that unit rate goes right here. Okay, go ahead and set it up, simplify, and determine if it's proportional or not. Hit pause, do it, and then we'll see what you got. Okay, so when you look at this one, really, as soon as two of them come up where they're not equivalent, so these two are not equivalent, as soon as you have one that's not the same as the others, it's not a proportional relationship. Because here we have a unit rate of 2, and here we have a unit rate of 4. You're done. You just say not proportional, doesn't have the same unit rate. And if it doesn't have the same unit rate, there's nothing that's going to go in there. Okay? Because you just said it's not proportional. So it's not a constant of proportionality. When you look at this one, they are equivalent. 4 is equal to 4 equals to 4. So that means this is proportional. So yes, it's proportional. Why? Because they have the same unit rate. So that's what you write, because they have the same unit rate. Okay? That's your answer. Okay? And then when you look at it, what is that rate? That's 4. So k equals 4. The constant of proportionality equals 4, which means it goes right here. Y is 4 times x. Every time, y equals 4 times whatever x is. So you can predict. Okay. So we have this one on your work. I'm not really sure what its point is, other than you should be able to do this. I'll probably just have you do this one in class, because this video is 20 minutes long now. And I really don't want them longer than 20 minutes. So we'll do this in class. You can do it now if you want, but I don't really, we'll talk about it in class. It's just, can you figure out the unit rates of each one of them and rate them from the highest, the fastest to the slowest? Okay? All right, guys. So this is all about, is it proportional? Understand that K is the constant of proportionality. Understanding that K is always by Y divided by X, and K only exists if each one of these is equivalent. So in this situation, it was proportional. In this situation, it is not. So there is no K, because it's not proportional, because there's no K. There's no constant of proportionality. Their unit rates are different. Okay, that's the gist of it. See you in class. Come with your questions.